Hello everyone, and welcome to today's webinar with Soda. Before we start on the topic proper, just a simple introduction to Soda as a company. Here at Soda, we have a simple mission, which is to empower everyone in your organization to share and use high quality data. So when it comes to sharing and using high quality data, this actually starts with gaining trust in your data. So whether it's data in reports for key decision making, or it's data in internal dashboards to improve operations, today we're going to show you how Soda can actually ensure data quality in your reporting processes so that the reports you provide are trustworthy and effective. So here are some of our customers, as well as some accreditations and compliance standards that we have achieved as an enterprise-grade data quality solution. So without further ado, we can jump into the actual webinar topic for today, which is how you can actually use Soda to detect bad quality data in business reporting. I'm Arthur, and I'm a customer engineer at Soda, where I help with product demonstrations as well as proofs of concept during the pre-sale cycle. And I also help with the implementation and successful adoption of Soda in organizations during the post-sales cycle. So joining me for this webinar is my fellow customer engineer, Tyler, who will be helping to answer any questions that you have. And you can ask these questions at any point during the webinar by simply typing them in the Q&A function as part of this Zoom webinar. This webinar is also being recorded, so it will be available for you to watch on demand as well as to share with other people who you know may be interested in this webinar after the end of this webinar. So if we have a look at the agenda for this webinar, firstly, we'll be having a look at the use case where we see an example of bad quality data in the business operations department at a fictional company called ADOS. The next main topic would be looking at how Soda helps organizations and users to detect such bad quality data by allowing users to create no-code data quality checks and to establish data observability in the Soda Cloud user interface. Finally, we'll also have a look at how Soda allows organizations to prevent data quality issues by allowing operational data quality and pipeline testing using the Python-based Soda library. So here is our use case for today, where we have some sales data at the business operations department in the organization ADOS. So here we can already see some bad quality data that is highlighted in purple. So you can see that there's an unexpected negative sales amount. So this is, as expected, going to cause some problems. For example, if this data is used to produce a sales report. In this business operations department, there are two main profiles. So here we see that there are data analysts. So these people are usually proficient in business terms, in business knowledge, as well as processes. But they are not alone in this business operations team. So just like real life data teams, analysts are often working alongside engineering profiles. So people who are more technically skilled, and these people are actually responsible for maintaining code and implementing data pipelines. So now that we've seen an example of some bad quality data, here are some scenarios of bad quality data in business reporting. And we can imagine, and unfortunately, many of us are also familiar with such scenarios in real life data teams. So in the first scenario, we see, for example, that there is a lack of trust in data, and not just a lack of trust in the data, but there also is a lack of trust between data consumers and producers. So in this case, we see, for example, that a consumer of bad quality data, in this case, another team, the product team, they actually detect bad quality data before the data producer actually knows about it. So in this case, the business operations team. So this definitely creates a sense of distrust in data and between data teams in an organization, which is undesirable. The second scenario that we see is where Basically, this bad quality data has caused an issue in a sales report, in a sales dashboard, and this has led to a costly wrong business decision. So this is another instance, another scenario where we want to avoid in real life when it comes to bad quality data. And finally, we have the last scenario where we see that data teams, they might try and attempt to manually run, let's say, SQL queries or some other form of data quality check on a manual basis, which is very inefficient. So with these scenarios in mind, let's have a look. We see, for example, that this business team, in this case, an engineer has tried this data quality tool and platform called Soda, and this engineer has actually recommended for an analyst to try out this new data quality tool in Soda. And so let's jump into the Soda Cloud user interface to see how an analyst can actually go about setting up a data quality check, in this case on the dataset fact internet sales, so ensure that there are no negative sales amount in the data that is being used. So if we head over into the Soda Cloud user interface, here you can see a list of data sets that an organization has registered with Soda. So you can see that you can filter exactly which data sets are being displayed. And here there's also a search function. So in my case, I might want to search specifically for this data set called fact internet sales. And here immediately as an analyst, without having to do any coding or any programming, I can immediately have a high-level overview of the data quality for this particular data set. For example, you can see the total number of checks that are being executed on this data set. There's also a percentage health, which basically shows you the percentage of checks on this data set that are passing as a percentage of all the data quality checks on this data set. There's also a nice calendar view of incidents that have been raised for data quality checks on this dataset. Further below, we see a list of data quality checks that are already being executed on this dataset. And here we see a traffic light indication system where red means a check has failed, green means a check has passed, and there's also yellow where a check is giving a warning. So as an analyst, before I actually proceed to create a new data quality check on this data set, what might also be helpful is some column profiling where I can get some high-level statistics of columns and their values in this data set. So this column profiling statistics are actually dependent on the types of values that we expect in the column. For example, here we have due date, which is a varying character column. So you can see more varying character specific statistics. For example, the minimum, maximum, and average length of values to expect in this column. There's also, of course, for example, a distinct count of the number of values in this column. Whereas if we scroll further down, for example, to have a look, in this case, in the column of interest, which is the sales amount column, here you can see more numerical specific statistics. For example, the average standard deviation as well as variance of values in this column. There's also a histogram showing a distribution of values to expect in this column. And here as an analyst, I can see, for example, that there is probably something wrong where there are negative values and many values between negative 4.99 as well as 36.48. So with the high-level overview of data quality for this dataset, as well as more information about the columns and the values that they contain, I can then proceed to add a new data quality check. Here we see, for example, many out-of-the-box checks. So without much training, without much necessary guidance, a business analyst can immediately click on one of these. They can simply fill in a form and they can get cracking on their new data quality check. But worth mentioning here is that Soda actually also supports SQL when it comes to defining your data quality checks. So earlier on, if you recall, we mentioned a scenario where data analysts, for example, could be manually executing SQL queries, for example, every morning on a daily basis to check for data quality. So with Soda, you can reuse your existing SQL queries, you can create new ones, and you can simply attach them to what we call a scan definition so that these SQL queries will be scheduled and executed on a regular and automatic basis without having to do so manually, which is very inefficient. Besides being able to execute these SQL queries on an automatic and regular basis, here you can also see that you can leverage built-in generative AI. So if I can give an example of a prompt. So here, if I provide this prompt, so basically for our scenario, we have this fact internet sales table where we suspect that there are negative amounts in the sales amount column. We can simply work with the generative AI assistant, which will then suggest a suitable SQL query, as well as an explanation of why this query was suggested. And once you're satisfied, you can simply insert it and improve and finally finalize this new data quality check. But in my case, I might prefer not to work with SQL, and I can then choose to work with one of these out-of-the-box data quality checks, which will redirect me to a form like that. So here I can give, for example, that I want to call this check sales amount not negative. And as mentioned, we can attach this check to a scan definition, which basically defines the regularity at which this check will be executed. So when you click on this dropdown, you can see a list of scan definitions that already exist. But if none of these are actually suitable, users can also create and customize their own scan definition. In the next step, we can also introduce filters for our data quality check. And this is particularly useful, for example, to optimize on compute resources and for efficiency, where, for example, we can just execute this data quality check on a subset of rows in your dataset, instead of executing this check on all the millions or even billions of rows that your dataset has. But in my case, I do not need filters, and I will then proceed to define exactly what I want to check when it comes to validity. In my case, I want to ensure that the sales amount is not negative, but here you can see a drop down of basically the different types of rules that you can use when it comes to defining validity. So here, for example, you can define a format that you consider either valid or invalid, where a drop-down list of formats that you can use are provided, for example, to ensure that the value is either an integer, a decimal. There are even formats, for example, IP addresses, dates, as well as email addresses and phone numbers. Besides specifying a format, you can even provide a list of values that you consider either valid or invalid by separating these values with commas. There's also the option to leverage regular expression, where you basically specify a pattern that states what is valid and what is not valid. And just like with SQL, here in Soda, we have built-in generative AI. And here in this case, I've clicked on a prompt to ask for a regular expression pattern to validate country codes. And here, once again, you can see that the AI assistant has suggested the regular expression pattern as well as an explanation. So if you understand the explanation and you're satisfied with it, you can simply click on Insert Regex and it will become part of your new data quality check. But in my case, regular expression is not necessary. I just want to ensure that all values in this sales amount column obey this validity rule, which states that the minimum value expected in this column is 0, which basically means that I do not expect any negative values in this sales amount column. Once that is defined, the next step would then be to define the thresholds at which we consider this check to have failed, won, or a combination of both. So in my case, I might just want to say that this check has failed when there is at least one row that contains a sales amount that is less than 0, So besides specifying these thresholds as an absolute number of rows, you can also specify them as a percentage of rows. And the final section in this form is attaching attributes to this check. So attributes are a very powerful feature in Soda. You can see attributes a bit like tags or metadata, which you can attach to either checks or to data sets. So an example of an attribute would be tagging this check based on the dimension it belongs to. So in this case, it is validity. You can also, for example, tag this check to which team it should belong to. Let's say it should belong to sales. And since the product team, as we saw in the scenario, they had some complaints about this negative sales amount. So maybe we can also tag them so that they can stay aware of issues in this data quality check. And besides single and multi-select attributes, attributes can also be free text. So you can, for example, put a link as an attribute, for example, to a certain piece of documentation in your organization. Attributes can also be numerical. So in this case, for example, because of all the problems that this negative sales amount has been causing, I might want to assign it an arbitrary number, let's say the highest possible weightage of 10. And this attribute can actually be used to calculate a weighted data quality score in your department or in your organization to give a more accurate picture of data quality in your department or in your organization. Once this form has been filled in, you can actually review whatever you have filled in the SODA checks language. So this SODA checks language is actually a domain-specific language. It's more technical. It's a YAML-based language, but you can see that it also remains very human-readable. So in one quick glance, you can see immediately that this check is for this particular table, fact internet sales. And you can also understand that it's basically trying to count the number of invalid values in the sales amount column, where the valid minimum is 0, as well as other configurations that we have specified for this data quality check. Here we also see a button where a user can test the check, which basically does a trial run of the check without actually saving any results. And here we see that I have two options to either propose the check or to add this check and directly schedule it in production. So with role-based access control in SODA, permissions can be limited such that users can only propose the check without being able to directly add this check into production without, for example, peer review or the approval of the necessary people in the organization. So let's have a look at what happens when we click on the propose check button. Here we are redirected to the discussions feature in the SODA Cloud user interface, where we see that a proposal has been created for that new data quality check that I was filling that form in for. So here you can see that other users in the organization can be roped in, where they can basically drop comments, they can engage in further discussion over this data quality check. By clicking on review, they can also see exactly what I have filled in for this new data quality check. They can, of course, change certain values and propose an alternative. Or if they have the necessary authority and permissions and they are satisfied with this new data quality check, they can approve it and add it and schedule it such that it will be executed based on the scan definition that this check has been attached to. So here, for example, you can also see a preview of the result of this data quality check. So if we quickly head back to the slides at this point. So what we have seen basically is how, with the SODA Cloud user interface, a business user who is not proficient in like coding or Python can very easily, with minimal guidance, and also with the help of generative AI when necessary, create their own no-code data quality checks, and they can do so in a very self-serve manner. And not just data quality checks, but they can also create discussions around these data quality checks to detect bad quality data. There's also, with these data quality checks, there's also data observability, which allows users to monitor data in your production data warehouses and also to create notifications and alerts around these data quality checks so that the right people can debug and fix the data pipelines that are causing such bad quality data. But there are two key limitations when it comes to this purely detection approach to data quality. So as you can see from that comment from analyst Ash, that in the first instance, if you see all the notification bells, there is this very common occurrence of notification fatigue, where users keep receiving alerts of bad quality data without actually knowing where, why, or how such bad quality data should be fixed once and for all. The second key limitation of just detection of bad quality data is that this bad quality data is often detected in your production data warehouse, whereas such bad quality data often originates earlier on or more to the left of your data pipelines. So there should be a way to basically stop such bad quality data when they are produced instead of waiting for such data to pollute your production data warehouses. So that is where SODA wants to take data quality to the next level by allowing users and organizations to take a preventative approach to data quality. So how does SODA basically allow you to prevent bad quality data? The first key capability is what we call operational data quality, where with SODA, you can basically direct data quality issues to data owners and to the sources of data so that a problem can be applied at the root cause. The second main capability is what we call pipeline testing, where with SODA, you can basically embed your data quality checks in your data pipelines so that you can test the quality of your data as early and as frequently as possible, and also prevent known data quality issues from happening over and over again. So now if we quickly head back into the SODA Cloud user interface, and if we have a look at how SODA basically allows you to do operational data quality. So here, if we have a look back at our fact internet sales table, imagine that we already had that data quality check to check for negative sales amounts up and running for a long time already. We can search for that check. And here immediately, when you jump into that check, you can see a historical view of the performance of this data quality check. And by clicking on different data points, you can see exactly with what value this check has failed, for example. Besides being able to see this historical view of the performance of this check, in the SODA Cloud user interface, we also provide what we call the failed rows analysis, where a sample of the failed rows that caused this check to fail are provided within the user interface so that it makes it very easy for users to immediately start investigating and diagnosing exactly what went wrong with this data quality check. So here in this case, a sample of rows where the sales amount is negative have been provided in the UI, and analysts can then take further action to identify, for example, any patterns in these rows that failed. Another key step in operational data quality is directing data quality issues to the owners as well as to the sources of the data. So within the SODA Cloud user interface, you can see that there is a function to create incidents. So for example, here I can say that sales amount negative. So I can give this incident a title, a severity, as well as a description. I can link it to certain failed data quality check results. And once that is saved, an incident will be created within the SODA Cloud user interface. And if I click on it, you can see, for example, more information about this incident has been created. You can see, for example, that the relevant users can be added and involved in this incident. And here, for example, you can see two key integrations. And if we have a look at these, for example, here, we can see that once you have set up integrations, for example, with Slack, you can see that a Slack channel has been created within your communication tool where users from around your organization can be added so that this incident can be taken care of and prioritized. Earlier on with this Slack integration, when I proposed that data quality check, you can see that with this integration, notifications can also be sent to Slack channels, for example, where the relevant people in the Slack channel can then immediately take action on that new proposed data quality check by simply clicking on that button and being immediately redirected to the SODA Cloud user interface. So these integrations with notification tools do not just work with Slack, for example, because SODA supports webhooks. So you can imagine doing the same with other popular communication tools, such as Microsoft Teams, as well as with emails. So if we quickly head back to the incident, besides integrations with communication tools, SODA can also be integrated with popular ticketing tools. So here, for example, you can see that by creating an incident in the SODA Cloud user interface, by setting up an integration with Jira, a ticket has also been created in Jira. And here you can see, for example, that the title as well as the description of the ticket is also sent into your ticketing management tool, and the status as well as other aspects of this incident can also be updated bidirectionally. So that is for operational data quality, where you can basically fix your data quality issues by raising incidents, as well as by diagnosing them with a sample of the rows that cause the check to fail. As mentioned, another key capability when it comes to preventative data quality is pipeline testing. So here with SODA, we provide basically a Python-based tool to allow you to embed your data quality checks in your data pipelines. So without going into too much technical detail, using the Python soda library just requires an environment that can run Python and where you can install the necessary soda library. So here you see, for example, that I am pip installing the soda library, let's say, to work with data in a Spark data frame. So worth mentioning here is that you see this example where I'm reading in a CSV file into a Spark data frame. Soda does not just allow you to run data quality checks on popular data SQL-based data warehouses like Snowflake and Databricks. With this Python-based Soda library, Soda also supports the execution of data quality checks on any data that can fit in a Spark, Pandas, or Dask data frame. So in this case, you see, for example, if I have some data that is in a CSV file, by simply reading this CSV data into a Spark data frame, I can then proceed to execute Soda data quality checks on this data. So once we have installed the Soda library, and once we have prepared the necessary data, in this case in a Spark data frame, we can simply import the Soda scan object from the Soda library that we've installed. And here, for example, you see a list of checks that I want to execute on this Spark data frame. So this checks and how it is defined should be familiar because we saw this earlier on in the Soda Cloud user interface as well. So these checks are also defined in the Soda checks language. So once again, this is a more technical language, and you can see it as a bridge between business users who create the checks in the Soda Cloud user interface, as well as technical users who can implement data quality checks programmatically as part of your Python-based data pipelines. So here we see a list of checks that have been defined. So worth mentioning here is that these checks can be defined as a string, or because Soda checks language is a YAML-based language, you can simply organize and place these checks inside a YAML file and point the Soda scan object to pick these checks up from the correct YAML file. Besides defining the checks, another important step would be to set up some connections. So in this case, we would have to define a connection back to Soda Cloud so that all the checks that we execute as part of data pipelines, all the checks as well as their results are also pushed back into the Soda Cloud user interface so that, for example, business users can diagnose any of those check results and also raise any necessary incidents to fix bad quality data. So just like with the checks, you can either define your connection configurations as a string, or you can also put these in YAML files. Not shown here is another important configuration. In the event that you are running data quality checks on your SQL-based data warehouses, another connection configuration would of course be the configuration details to connect with your data warehouse. But in this case, this is not necessary because I'm working with data in my Spark data frame. So once we have defined the checks and once we have defined the connection configurations, the next important step would of course be to execute the data quality checks. Further on, we see some key methods as part of this pipeline testing that is usually very useful. For example, we can print the logs of the check that has been executed. So here you see in a very human readable format, a summary of the status of the checks that have been executed. There's also a final summary of how number of checks that have either passed, failed, warned, or given an error. And here also some confirmation that these results have also been sent back to the Soda Cloud user interface. Another important method is what we call circuit breakers. So when it comes to detecting bad quality data, these circuit breakers are very useful to see exactly at which stage of your data pipeline, for example, bad quality data has been detected and also prevented. So in this case, this circuit breaker says assert no checks fail. And you can see that in this case, because 2 checks have failed, this circuit breaker has actually been triggered. And you can see that this final print statement has actually not been executed because the execution of this entire notebook was basically stopped by this circuit breaker. So you can imagine, as mentioned, this is a more preventative approach to data quality by stopping the bad data where it originated instead of allowing it to flow into your production data warehouses, for example. Another important method would be this get scan results, where instead of getting the results as a human readable log, you can get those same results, but in a more programmatic and more Pythonic way. So here you see these scan results as a Python dictionary, and you can imagine manipulating these results as part of your pipelines to basically control the flow of your pipelines depending on how your data quality checks have performed. So if we quickly head back to the slides once again. So to summarize all the capabilities that Soda offers when it comes to data quality in terms of detection as well as prevention, here we see an overall view of these capabilities. On the left, we also worth mentioning is that Soda basically wants to break down the silos between the more technical personas, as well as the more business and more data-oriented personas. So here, for example, you see that Soda allows both technical and business personas to collaborate and work on data quality instead of trying to push this responsibility between these two silos. And of course, as mentioned, we have the two main capabilities in terms of the detection of bad quality data, where we allow users to set up data observability and also to create their own no-code business checks using the Soda Cloud user interface. And of course, as mentioned, because of the limitations when it comes to just the detection of bad quality data, Soda also wants to allow users and organizations to prevent bad quality data by allowing for pipeline testing as well as operational data quality. So at this point, it seems like we are in good time. So I'm wondering if Tyler, at this point, are there any key questions that you can share and that I can also answer and share with the rest of the audience?
Hey, Arthur. Thanks. There is one question that I think is interesting. The question says, are there other ways to detect data quality besides just the notifications, especially with an overview of data quality? They give some examples like a dashboard or a catalog integration.
Right, so other ways of detecting bad quality data. Okay, thanks for sharing that question, Tyler. So indeed, besides the examples, as we saw where we set up a notification with, let's say, Slack or Microsoft Teams, where users can be notified of a detection of bad quality data. Indeed, Soda also integrates with, for example, a catalog as well as dashboarding tools to give you a better overview of poor or bad quality data in your organization. And this is mainly done because Soda provides the Soda Cloud API from which you can extract all the data quality information that you see in the Soda Cloud user interface. So right now, what you're looking at is an example of a Soda integration with a popular catalog tool. So in this case, it is Atlan. So here we see, for example, that by integrating Soda with Atlan, here we see an asset, which is the same fact internet sales table that we've been looking at during this webinar. And here you see, for example, that with this integration under the Soda widget, you can see, for example, a summary of the Soda data quality checks that have been applied to this data set, and also a summary of the number of checks that have passed and which have failed as well. And here also a list of all the data quality checks that have been executed on this asset. So if we click, for example, into one of these checks, we can also get a better idea of exactly what each check is trying to achieve. So with this integration with catalog tools and with the idea of having an overview of data quality in your organization, with catalog tools, with the lineage function, you can see that, for example, with such an integration, in a catalog tool with widgets like this, you can basically enrich all your lineage views and overviews of data in your organization by having also the data quality information from Soda as part of these overviews. So another view of a lineage tool. So here, for example, you can imagine when it comes to detecting, for example, bad quality data in your reports by having Soda embedded here, for example, with the overview of data quality of different assets that lead up to your reports, you can basically have a better understanding of the overall data quality health of any of your data products. So as part of that question, besides catalog tools, with the integration with visualization tools, Also via the Soda Cloud API, you can basically work with popular visualization tools. In this case, we see an example of a Power BI dashboard, but you can also imagine doing the same with popular visualization tools such as Tableau, Looker, and any other visualization tool, where we see that with the information extracted via the Soda Cloud user interface, you see not just simple overviews of the number of assets and the number of checks that you have, but you also see, for example, the ability to create very spliced and very next level visualizations. For example, seeing the number of checks that you have, depending on which data quality dimension, which pipeline stage, which domain, or which team they belong to. And here also, you can see that you can calculate a more accurate data quality health score. And all this is also possible because, as mentioned, you can tag your data sets as well as your checks with attributes, for example, to indicate whether the check or the data set belongs to a certain data quality dimension or which team it belongs to, and also to tag your checks with a numerical weight to basically give different checks a different level of priority. So with that question, that also leads us to some of the final slides for this webinar. So here we see, we saw not just the product capabilities of Soda, but this slide also demonstrates how Soda integrates very well in the modern data stack. So at the center, we have Soda, which is our software as a service. It is cloud hosted. Soda can also be specifically the Soda agent, which connects to your SQL-based data warehouses. This Soda agent can be hosted on popular cloud platforms such as AWS, Azure, and GCP, and the only requirement is Kubernetes. And on the left, as mentioned, Soda does not just work with SQL-based data warehouses. We also allow the execution of data quality checks on any data that can fit in a Spark, Pandas, or Dask data frame. And as demonstrated with the Python-based Soda library, this allows organizations to embed your data quality checks in any environment that runs Python and can install that Soda library. So you can imagine adding Soda data quality checks to popular orchestration tools such as Airflow and Darkster. And then on the right, as we saw in the final question that Tyler shared, Soda can also be integrated with popular metadata as well as dashboarding tools. And once again, this is possible with our Soda Cloud API, where you can extract all the data quality information that your users see in the Soda Cloud user interface. And finally, as we also saw, because Soda supports webhooks, so you can set up integrations with popular tools for communication, such as Slack and Microsoft Teams, as well as ticketing tools such as Jira, as well as ServiceNow. So to end off the webinar, here are three. Let me head back to the slide. Here are three next steps that you can actually take to start detecting bad quality data with Soda. So the first step is where you can join us on our Slack community and also join fellow like-minded data professionals, where you can basically discuss and share any questions or any insights that you might have when it comes to ensuring good quality data in your sales reports or in your business reports, for example. Another step that you could take is to schedule an introductory meeting as well as a demo with, for example, myself, Tyler, as well as the rest of our sales team, where we can actually understand your use cases and see how Soda can actually help to address them. And finally, if you prefer taking things at your own time, you can explore our public, very detailed step-by-step documentation at docs.soda.io to get a better idea of all the features that Soda offers. And it seems we are ending in good time. So with that, that comes to the end of today's webinar. I hope you have now a better understanding of how Soda can help you detect bad quality data in your business reports, as well as in other business processes that your organization has. So on behalf of Soda, thank you once again for your time, and we look forward to working with you for high quality data in your organization. Thank you and have a good day.